Section 3.6, Dividing Polynomials. This is a fairly short section. We've already done problems similar to this. 20a to the 7th divided by 5a to the 5th. We've talked about problems like this. In order to go through and divide this, all you're going to do first of all is just divide the coefficients here. 20 divided by 5 gives me 4. And then I'm going to divide my variables with the exponents. A to the 7th divided by a to the 5th. Remember, you subtract the exponents. 7 minus 5 gives me 2. So the final answer to this is just 4a squared. What we're going to do in this particular section, though, is we're not just going to be dividing monomials, which is really what I had there. Now we're going to start talking about dividing with polynomials. So, for instance, if you are given something similar to this, 3a plus 6 divided by 3, now what I need to do is I need to divide both the 3a and the 6 by 3. Now there's several different ways of doing this. Some people like to rewrite this problem, and you could, if you wanted to, rewrite this problem 3a over 3 plus 6 over 3 if you wanted to, because when you put it back together again, you're going to get the same thing because you have the same denominator. In this particular case, I would just go through now and I would divide 3a divided by 3, which means the 3's cancel. I'm just left with a. And then I would divide 6 divided by 3, and I would get 2, so my final answer is just a plus 2. Many people, though, would rather not rewrite it. Just remember that with this 3 that I have in the denominator, I'm dividing both of these terms, the 3a and the 6 by the 3. So I could go 3a divided by 3. Once again, the 3's cancel. I'm just left with a. Then I'm going to divide 6 divided by 3. 6 divided by 3 gives me 2. I still get the same answer that way, a plus 2. Just remember you are dividing both terms in the numerator by the denominator, 3. Here's another example. I'm going to go through and do it both ways again. So if I'm going to do it that first way that I talked about, I would rewrite this as 28a to the 3rd over 7a subtract 42a squared over 7a. Doing that then, I'm going to divide the 28 divided by 7, which gives me 4. A to the 3rd divided by a gives me a squared. Subtract 42 divided by 7 gives me 6. A squared divided by a gives me a, which is the final answer to that problem. I can also, though, I can do it the other way. I'm just going to keep everything the way it is. I'm going to divide 28a to the 3rd divided by 7a, and once again, the 28 divided by 7 gives me 4. A to the 3rd divided by a gives me a squared. And then I'm going to go through the 42a squared over 7a. It is subtract, because this is a subtraction sign here. 42 divided by 7 gives me 6. A squared divided by a gives me a. I get the same answer either way. Here's one final example. Before I do it, you might want to turn it off, do it yourself on a piece of paper, and check and make sure your answer. I am going to go through and I'm just going to do this the second way that I've been doing. So when I do that, first of all, I'm going to divide 9x to the 3rd divided by 3x squared. The 9 divided by 3 gives me 3. X to the 3rd divided by x squared just gives me x. Then I'm going to divide the 12x squared divided by 3x squared. 12 divided by 3 gives me 4. Now remember I have an addition here, so I put down my addition here. And as I said, 12 divided by 3 gives me 4. And in this case, the x squared and the x squared cancel. So I am just left with a final answer of 3x plus 4. As I said at the beginning, this video is fairly short and fairly straightforward. But as always, please let me know how I can help if you have any questions. Thank you.